University's Industrial Skills Centre in Werribee hosted the 2005 Formula SAE Australasia competition. 25 teams included 2 from Japan and 1 from both New Zealand and India. First held in 2000, Formula SAE now has a permanent home at Werribee. Will van der Werf is one of the judging panel.
Well, I'm actually looking at, after all, the ergonomics of the vehicle, the way the vehicle's finished. Okay, so I look at the overall appearance, any sharp edges on the vehicle, cables that are loose, and you know, the steering shaft where it goes between the driver's legs, or if there are any bolts that could harm the driver. So just basically from a driver-friendly environment for the cockpit. Some like 5 judges, each looking at different areas, but we are a cross-functional team. So we get an overall view of the car and then get together later and doing a judgment of the vehicle. We got electrical, we got powertrain, we got chassis guys. Okay, I just happen to be looking after the aesthetics and ergonomics of the vehicle. It's pretty good, really. It's quite amazing what these guys achieve in 1 year. So yeah, quite pleased.
Formula SAE cars are aimed at the non-professional autocross, or as it's better known in Australasia, sprint and hill climb driver. The car needs to have high performance and safety, simplicity of manufacture and ease of maintenance. After a year of designing, fabricating, building and testing, teams are required to sell their design to a racing car manufacturer. The goal is to produce 4 cars a day. A total of 1,000 points are available for static and dynamic events. The engineering design event is worth 150 points and rewards the concept and execution of the car.
So what that means is, as an amateur driver, he can have the roll spring set to be very, very soft to make the car stable, and as he improves, he can pump that up to get the car to be much more stiff and roll, more responsive.
The University of Western Australia was the winner, ahead of RMIT, Tokyo Denkai and Wollongong.
The traction of the other 3 tyres are not going to be compromised.
Paddle shift gear.
Full bore racing from Swinburne with Chief Engineer Colin Byrne.
Pneumatic cylinders actuate the gear shift and the clutch and are powered by a customized CO2 system. The ignition cut on the upshift ensures that the change can occur even when the driver's got his foot flat to the floor, and releases the paddle, allowing the driver to match the revs for his all that timing is controlled by a custom microcontroller on the dash, which communicates with the ECU to allow automatic shifting for the acceleration and conducted experiment
What thought, if any, have you given to side impact?
Well, side impact this year, the rules changed, so this part is allowed.
We set forth a little over
In the presentation event, 75 points are on offer. Teams face a panel of industry experts. They have to show what is required to build the cars, demonstrating knowledge of both engineering and manufacturing procedures.
It's also a chain drive that utilizes a lifted slip differential to ensure no complete loss of torque and allows transfer of torque.
UWA took equal first place with RMIT, and third, the University of Auckland.
Conventional machines.
And in the cost event, 96 points out of 100, and the win to RV College from Bangalore, India. Wollongong second and UWA third. Technical inspection and scrutineering ensures that the cars are ready for the competition, meeting safety and mechanical specifications. Michael Royce from the SAE was in charge.
For the cooling system. Check all the. This is way too loose. Okay? So, first thing. Through, pull, tight, really tight. Come on. Okay? Okay.
Helmets have to be inside the safety envelope.
Oh, it's good.
And the drivers have to be able to exit the cockpit in under 5 seconds.
3, 2, 1, go. 2.4 seconds. Okay, good. Well done.
When you get to the test track, you will push your car onto the track, and then the team will come off the track.
Briefings take place each morning. Last-minute adjustments for Wollongong University's Steel City Racer, the defending champions.
If I get a card, I can write in an email.
Over the 3 days of competition, all 4 seasons were experienced. Day 2 of the 2005 Formula FSAE Australasia competition. After passing scrutineering, the car is filled with the prescribed amount of fuel. On the tilt table, the car is taken to 45 degrees and no fuel can leak. At 57 degrees, representing a cornering force of 1.5 G, the upper wheels must remain on the table. Noise measurements come next, and the engines must be under 110 dBA at 0.5 of a metre from the exhaust pipe, on a sweep to 75% maximum revs. All 4 brakes must be shown to work, and that the engine can be switched off externally. Some brakes work better than others.
And welcome to a windy Werribee this morning.
Teams must complete all these safety tests before they're able to compete in the dynamic events. The skid pan measures the vehicle's maximum cornering capability through a tight left and right-hand circle. Teams are allowed 4 runs in total and 50 points are available. The acceleration event focuses on engine performance, transmission and suspension design over a 75-metre sprint. It's worth 75 points. We talk to the teams about their cars, how they've gone about preparing, the composition of their members and what they hope to achieve.
This year we've got 3 or 4 first-year students and a couple of second-year students and some third years. Brand new car. Yep. Our Swimmer's philosophy is success through evolution. So every year we just upgrade parts, and rather than starting from scratch every year. So we don't try not to reinvent the wheel as it was. Probably the newest thing on this car, and something that no other car in the competition's got, is 4-wheel steering that we've trialled for the first time this year. Well, with the tight nature of the SAE tracks, turning radius and change of direction of the car and manoeuvrability is really critical, and the 4-wheel steering system helps us out with that. We've done about 40 hours of testing this year, 40-50 hours of testing. Our main test track's at Calder Park. Usually we run about 25 students. This year it's quite a small team. We've got around, only got 10 final year students and a few second and third years. There's advantages and disadvantages for sure. Obviously it's a lot easier to control a smaller group. It's easier to get continuity between the team and make sure everyone's on the same page. But on the other side of things, it'd be nice to have a little bit more manpower for those extra jobs. Swinburne's been this project, this year. We start designing the car a couple of weeks after the previous event. So we design all the way through December. We have design freeze at the end of February and have the car built hopefully by the end of August. Swimmer's always been in the top 10. Our best result's been a 4th place in 2002, and obviously we aim to better that somewhat, and the ultimate goal is to win the competition. There's 2 areas: management area, controlling the team, working in a team environment, which is a really important aspect, and the other aspect, which I think is the most important, is the hands-on experience that engineering students just don't get if they don't do a project like this.
Swinburne was 4th in the acceleration and 8th in the autocross, having to deal with severe axle tramp. Deakin Race Technologies has a Sidewinder-style car with a wide front track and a short wheelbase.
No, this is a brand new car this year. It's an evolution of a concept we came up with last year, but this is a brand new car for this year. We've improved every area of the car. The car is a lot faster than the last one. It's a brand new chassis which is 77% stiffer than the previous one. We've developed spoked carbon fibre wheels this year, and yeah, it's every area has basically been improved in some way. Currently at the university, well, it's obviously mainly an engineering-based project, but we do include the Faculty of Arts helps out with the public relations and sponsorship side of things, and the School of Information Technology also help us out with some stuff. And we're trying to increase all over the university, make it a university-wide project. I'd say team management and getting everything to happen on time is by far the most difficult. I think, and it's often underrated as to how hard that is, but that's basically, I think, what the project's all about, more so than the design. The design's not that hard. Actually, execution is probably the hardest thing, considering it's a voluntary extracurricular activity.
Deakin was 11th in the acceleration and 10th in the autocross, the low seating position causing some visibility problems. Queensland's University of Technology, despite on-track speed, was down the order in the dynamic events.
About 15 people involved in the team, ranging from first year through to fourth year. Designing and building various components of the car. Compared to Western Australia, they're 45 team members. Yeah, it's relatively small. Depends. It means you can have fewer people specialising on one particular area rather than several people working and having to coordinate together to work on one area. But yeah, it does stretch thin, especially through the building process. Completely new. Totally different concept of design to last year. So, well, it's obviously a totally new chassis, same engine, still a tube frame chassis and wishbone suspension, but I guess you need to really see the old car to compare them. But last year we had a few reliability issues with the rear hubs, which I'm fairly confident has been sorted out this year. As well as that, it's just handling a lot nicer car to drive, a lot easier to drive, a lot quicker in general. Getting a lot more power out. It's just new restricted design, better tuned engine. Intake's a lot better sorted than last year.
Wollongong had to revert to a manual launch in the acceleration test, taking 8th place. 15th in the skid pan was a disappointment, but the team bounced back to take 2nd in the autocross.
It's a faster car, it's better set up. It's got push-rod suspension, Owen's dampers, very strong engine package. We do a lot of refinement. You can't reinvent. No point reinventing the wheel each year. So this year we've had about 6 or 7 students carry over. Last year we only had 2, so we did a lot better in that respect this year.
The autocross tests the car's manoeuvrability on a tight 1 kilometre course, with the cars running solo. This is the test of just how quickly the cars can go in a one-lap sprint. 150 points are available. Monash University has been proponents of the winged Formula FSAE races. 10th in the acceleration and the skid pan, and 7th in the autocross.
The year's gone pretty well, fairly smoothly. You never get everything done as quickly as you want to, but we've had a bit of driving time. We've probably had a couple of weeks of solid testing, like 10 days testing, something like that. Always hard to find a test venue, but we've managed to find some time to do that. So we're fairly confident and happy with the reliability of the car and just looking forward to getting into it.